Okay, on this one, I'm just going to talk about a couple of inequalities. I want to focus on linear inequalities in this video. First of all, you could have just a straightforward linear inequality here, like 3 times the quantity 2x minus 7 is greater than 12. And then if you distribute that, 3 times 2x is 6x, 3 times minus 7 is minus 21. And then you just kind of like you do with equations, you can add the same number to both sides. So add 21 to both sides and you get 6x is greater than 33. And if you divide both sides of an inequality by a positive number, which is what I have to do to finish this, divide both sides by 6. When you divide both sides by a positive number, the inequality keeps its true form. What you have to be careful of is when you divide both sides by a negative number, then the inequality reverses direction. And so, but here I'm dividing by a positive number. I'll divide both sides by 6 to get x is greater than 33 over 6. Now, whatever the form of the inequality you start with, that's what you're going to keep. So if this is greater than, then here it would stay greater than. If it was greater than or equal to, then it would stay greater than or equal to all the way through. Or if it was less than, it would stay less than. If it was less than or equal to, it would stay less than or equal to. As long as you're not multiplying or dividing both sides of the inequality by a negative number, that would cause it to flip over. Okay, so that's basically a linear inequality. Now, an absolute value inequality is similar. It's basically this absolute value inequality is basically a linear inequality, but it's what we call a compound inequality, and I'll show you what I'm talking about. Now, just like I showed you before on some other expressions, you want to isolate the absolute value expression. So one of the tricks we do to students is we give them something like this, and they forget to eliminate this 3 before they start. So the first thing you'd have to do is subtract 3 from both sides. And then once you do that, then you get the absolute value is greater than or equal to 9. I had to use a different notation, but this greater than or equal to is just the same as this right here. So anyway, 2x, the absolute value 2x minus 7 would then be greater than or equal to 9. Now, that's actually going to give you 2 sets of answers, and let me show you why. Remember that when you have an absolute value expression, it's equal to positive the expression or negative the expression. So this is like saying, okay, 2x minus 7 is greater than or equal to 9. Alright, well we have to solve that. I'm not going to lie to you. We have to solve that. 2x minus 7 is greater than or equal to 9. But the other thing that's true, remember, the absolute value is also true if the expression is negative. So we also have to solve this equation. Minus the quantity 2x minus 7 is greater than or equal to 9. But we're going to write that a little bit different. If you multiply both sides of this by negative, if you multiply this by negative, of course, that would get rid of that negative right there, and you just have 2x minus 7. But remember, when you multiply inequalities by negative, it's going to flip it over. So you're going to flip it over. That's going to become less than or equal to. And then 9 times negative 1 is going to be negative 9. So basically, I'm just saying if you multiply both sides of this by negative 1, it's going to change to 2x minus 7 is less than or equal to negative 9. Now, you don't have to do what I did here every time. I'm just showing you that this is why it works out this way. So if you have absolute value of an expression greater than or equal to 9, then what you have, let me show you like I did with the equation a while ago. So if you have, let's say you have the absolute value of an expression greater than or equal to some number, some positive number, or not negative number. Well, then the way you solve that is you have to solve 2 inequalities. You do e is less than or equal to minus the constant, so e has to be less than or equal to minus the constant, and then e has to be greater than or equal to positive the constant. So you actually get 2 sets of answers, or 2 solution sets here. So here, in order to eliminate the absolute value, I have to say 2x minus 7 is less than or equal to negative 9, or 2x minus 7 is greater than or equal to positive 9. Once you get to that point, then you've just got two inequalities to solve. If I add 7 to both sides here, I get 2x is less than or equal to negative 2, so x is less than or equal to negative 1. So the solution, all values less than or equal to negative 1 will satisfy this inequality. Let's see what the other set is. Here, if I add 7 to both sides, I get 2x is greater than or equal to 16, and then divide both sides by 2, I get x is greater than or equal to 8. So there's two sets of solutions. It's all values less than or equal to negative 1 plus all values greater than or equal to 8. So, and actually that's like a union of two sets. So again, two sets of solutions. Now, for the less than case, let me show you a less than example just so you'll know what to do in that case. So for the less than case, if you have the absolute value of an expression less than or equal to a constant, then what you do is you set the expression between the negative constant and the positive constant. So here I have the expression is greater than or equal to negative k and less than or equal to positive k. So for this problem, here's an example of that. I have the absolute value of 2x minus 1 is less than or equal to 5. So I take that expression and I put it greater than or equal to negative 5 and less than or equal to positive 5. But then you still have to solve this because you want to figure out where x is. What's the solution for x? So what I did is, to eliminate this minus 1, I add 1 to each side. So add 1 to negative 5 and I get negative 4. Add 1 to plus 5 and I get 6. And then of course if I add 1 to the middle, the negative 1 cancels. Well, then you have to isolate x. Here you have 2x in the middle. So if you divide negative 4 by 2, you get negative 2. If you divide 6 by 2, you get 3. And of course, if you divide 2x by 2, you get x. So basically, the solution is all values from negative 2 to 3. So any number from negative 2 to positive 3. And since it's greater than or equal to and less than or equal to, it includes the numbers negative 2 or 3. Now, if I didn't have the equal to there, I would just, I'd do it the same way, but I wouldn't have the equal to as I solved it. So in this case, then the answer would just be only the numbers between negative 2 and 3 and not including the numbers negative 2 and 3. And so that's how you solve linear inequalities and absolute value linear inequalities.